Okay, this is our final video for section 5.9, and it's operations with complex numbers. Now, in our previous video, the one we watched just before this, we just talked about the BI part of a complex number. Remember, a complex number contains I and is in the form A plus BI. We're going to look at that whole complex number now, the A plus BI part. And when we talk about operations, we're just going to apply ideas we already know. Okay, things like FOIL or adding and subtracting. We already know these things. The difference is that we're going to treat them with that I. It's going to have that I in there. So we have to remember that I squared, if we ever see that, equals -1, so that we can switch that out. That's the only real thing that's different in this section, in this set of notes here. Everything's going to be an idea we've already done before, except for that I squared part. So we got 5 examples here. The first example is adding complex numbers together. So we have, in parentheses, the first complex number, 6 minus 4i, and then our second complex number, 1 plus 3i. Really all we're going to do is combine like terms. Well, I have a 6 and a 1. They're being added together. 6 plus 1 is 7. I have -4 plus 3i. That gives me a -1i. So there's my answer. 7 minus 1i. And I could write that 7 minus I. There's no real reason to write the 1 unless you just want to see it there. Okay? But that's all we're doing. We're just combining like terms. Something we've done before. Subtraction of complex numbers is the same idea. The difference is we have to distribute this negative. So we have 4 minus 6i minus 3 minus 7i. And we take that negative and distribute it through. So now we have 4 minus 6i minus 3, because a -1 times 3 is -3, and -1 times a -7 would be plus 7i. Now we combine like terms. 4 minus 3 is 1. -6i plus 7i is going to be plus 1i. We don't need to put the 1 in front of the I, so we have 1 plus I. There would be our answer to the problem. Okay? Again, nothing we haven't done before. Next idea, FOIL. FOIL stands for, again, first, outside, inside, last. And I will warn you on this one, you most likely will get an I squared, so you're going to have to switch that out. We have 2 plus 3i times 4 minus 2i. So we do the first. 2 times 4 is 6. The outside, 2 times -2 is -4i. The inside, 3i times 4 is plus 12i. And then 3i times a -2i gives us -6i squared. I times I is I squared. So we did get an I squared here. We're going to have to switch that out. Now let's combine like terms. Well, let's switch that out first. We have -6, and then I squared is -1. So -6 times -1 is going to be positive 6. So we end up getting 6 minus 4i plus 12i plus 6. Okay, now we combine like terms. There's 2 in the middle, -4i plus 12i. Well, that's 8i. And 6 plus 6 is 12. So there's our answer, 12 plus 8i. And as I was working that out, hopefully you caught my mistake. I did make a mistake here. 2, right here is where my mistake is. 2 times 4 is not 6, it's 8. So we need to go through and change that. So now, instead of being 12, we have 8 plus 6, which is 14. So our answer is 14 plus 6i. That was my mistake. Good for you if you caught it. If you didn't, you need to be paying more attention to my work. Hopefully you didn't make the same mistake either. But now our answer is 14 plus 6i. I will say that you do not want to write it like this. That is not the form for a complex number. Okay? A needs to be first, the BI part is second. So our answer is 14 plus 6i. Next thing we're going to do is we're going to look at a conjugate. And we talked about this in section 5.6 and in 5.7. This idea where we have something in the bottom, an expression with a radical in it, and we have to get rid of that. Now, it may not look like our problem here, 5i over 3 plus 2i, has a radical in it, but you need to remember that I is really the square root of negative 1. So even though it doesn't show that we have a radical in it, that I is a square root of a negative 1. So we do have a radical in the denominator. What we do, we're going to multiply by that conjugate of the denominator. So 3 minus 2i. Okay, that 3 minus 2i over 3 minus 2i, that's our well-chosen one. And we're going to use that to get rid of the I, which is really the radical, in the denominator. All right, so for our numerator, we have 5i times 3 minus 2i. And then in our denominator, we have 3 plus 2i times 3 minus 2i. And we're going to distribute the numerator and FOIL the denominator. Well, 5i times 3 is 15i, and then 5i times a negative 2i is minus 10i squared. I squared, remember, is a negative 1, so now we have negative 10 times negative 1, which becomes positive 10. So we have 15i plus 10, got to switch that around, 10 plus 15i, because we want it in that form, a plus bi. For our denominator, we've learned this trick, we can just first and last. Because the inside two, whenever they're identical and the signs, the only thing different, are going to cancel each other out, the O and the I. So let's just do first and last. 3 times 3 is 9. Oh. And then the last, 2i times minus 2i is minus 4i squared. I squared again is negative 1. So now we have 9 plus 4, which is 13. You do want to check and make sure that you don't have a greatest common factor in all of your numbers. There's nothing other than 1 that goes into 10, 15, and 13. So there would be the answer to our problem. If you did have a greatest common factor, you need to make sure that you take that out. All right, we have one more example. It's another example using a conjugate, but I put a star by it because it's a little different. We have 4 minus I over 5i. Now, we're going to use the idea of a conjugate. But there's only one thing in the denominator, and this is what catches people. That 5i is really 0 plus 5i. That's how we'd write it. It's a is our 0, and then b is 5, so plus 5i. When we use our conjugate, we're just going to multiply by a negative 5i, because it would be 0 minus 5i. And I don't need to put the 0 in there. So we just multiply the top and the bottom by negative 5i. I don't have to FOIL these now. It's just distributive and multiplication, which is nice. I just want to show you this example so that you can see that if you have a problem or find an example that has that in it. So now we've got negative 5i times 4 minus I for our numerator, and 5i times negative 5i for our denominator. Let's distribute the numerator. Negative 5i times 4 is negative 20i, and then negative 5i times negative 1 would be plus 5i squared. I squared is really negative 1, so now we have negative 20i minus 5, because 5 times negative 1 would be a negative 5, and we have to flip that around. We get negative 5 minus 20i. There's our numerator. Our denominator, 5i times a negative 5i is going to be negative 25i squared. I squared is really negative 1. Negative 25 times negative 1 is positive 25. So we end up getting negative 5 minus 20i over 25. This particular problem does have a greatest common factor. There is a number that goes into 5, 20, and 25, and that number is 5. So we would cancel them out. Negative 5 goes into negative 5, negative 1. 5 goes into negative 20, negative 4i. And then 5 goes into 25 5 times. So our answer is negative 1 minus 4i over 5. Okay, make sure you take the GCF out. If you don't get that far, if you don't remember to take that out, you'll still miss a few points, But you'll get the majority of the points because you've done the majority of work. You show you understand the concept. I do want you to take that greatest common factor out, though, so make sure you pay attention to that. All right, those are your notes on operations with complex numbers. It's stuff that you should have seen before, so if you do have any questions, be sure to either watch the video again or bring them to class next time.